Hello, everyone. We're back from the London Summit with the AWS Launchpad to talk about AWS IoT now and a specific part of it. And I'm joined by Amir. Could you introduce yourself and tell us what you do for Amazon?
Sure. Hi, everyone. Good morning, good afternoon. My name is Amir Majlesi. I work as IoT Business Development Manager for AWS. Quite excited to be here at the AWS Summit in London and talking about industrial IoT and the use cases that we see across the market. Okay.
And what kind of market segment are we talking about? And what's your specific focus inside that?
So specifically in the industrial sector, we see a lot of uptake in manufacturing. As an example, the other area is utilities. So a lot of utilities are starting to use IoT to better manage their smart grids and also to better manage the energy consumption and efficiency at homes. The next sector is transportation. All the car manufacturers are starting to use IoT to connect the cars and to use that data to make their cars better over time. And then the last one is also in the natural resources and mining, in the oil and gas and energy sector. IoT is being used to drive efficiencies and to help the oil companies increase their revenue.
Great. So we are talking not the garage IoT here. We're talking like the big scenarios, like big companies, predictive maintenance, this kind of thing. Yeah. Could you tell us a bit more about what defines industrial IoT and why does it matter?
Yeah, so industrial IoT is basically about using data from connected devices in the context of industrial use cases to drive efficiencies through the use of cloud, through the use of analytics and machine learning capabilities, and then use that insights that you drive from those data for having additional revenues, to introducing new business models, as an example, or to increase the operational efficiency across your supply chain.
Cool. And how is this business changing in the past times? Like, what is new and exciting in industrial IoT?
Yeah, so the biggest trend we see in the market is around connecting products to the cloud and getting that data to create new user experiences or to use that data to help the way improve the way that these companies are manufacturing products. For example, if you think about in the healthcare industry, if you think about a CT scan device, so today you go to the center, they take an image from you, and then you rely on the doctor to decide what's the diagnostic based on the image that they have from your body. But think that if that device is connected to the cloud, and then you have access to the thousands of similar images with the data available for each image around what type of disease it includes, what type of diagnosis we can have around that. And then you can match your image with those other examples to make much more accurate and much better decision about your own situation. So these are new type of experiences and new ways to introduce new services for your products. So one trend that we see in the industrial sector is around going from mass productions to mass customization and personalization. So all the products are being connected. You can collect data from these products, and you can use that data to make them better over time, and also change the way you engineer and you manufacture those products. You can actually use that data back in your R&D department to make better decisions around how you want to design and how you want to manufacture those devices. And the other trend that we see in the market is these new business models. So instead of offering your device to your customers to pay as upfront for your product, you can change the model into as a service model. So use the data that you have from your product to offer additional services for your products. And then the last trend is around efficiency across your supply chain. So when you have connected various parts of your supply chain, you have much more visibility across what's happening in your supply chain, in your manufacturing environment, for example. And then that can help you to automate a lot of processes and move towards what we call data-driven processes or data-driven disciplines, which helps you to reduce costs and to increase the operational efficiency for your processes.
Totally. I hear these cases, and I'm thinking the amount of human-machine relationship is very interesting. It's not about automating the human out of the task, but supporting better decision-making, better exploration of the facts, and in the end, better decisions and better business, right?
Exactly, exactly. So basically, you can introduce new experiences, how you want to interact with your devices and with your machines. By using the data that you collect, you can make your products better and better over time. And then also the way that you interact can be improved by using that data, using the analytics. And you can do these analytics on cloud, obviously. So cloud is an important element of the whole solution. But you could also add intelligence more to your devices using, for example, AWS Greengrass, which is our edge computing software. And it allows you to do things like having Lambda functions on the device, or for additional capabilities, you can even do now machine learning on your device to even make it more smart and more intelligent.
Wow, that's a lot of functionality. I believe that building this stuff must have its own challenges. So what are the specific challenges that you see in this industry? What is the hard part in this?
Yes, so I would say the top challenge is around security. Most of our customers, as they are connecting their assets and devices and customers to the network, they are concerned about the security. And if, for example, someone can compromise a device and they can use it to initiate an attack, or there could be fraud in their network. So that's one concern and one challenge for a customer, to make sure that they keep the security at a very high level. The other challenge is around scalability. So connecting a couple of devices is easy. But if you want to scale up to thousands and hundred thousands and millions of these devices, it becomes quite challenging to be able to manage those devices efficiently, to be able to provision new devices, and to update, for example, these devices. So that the scalability is another challenge that we see across the board. And the last challenge, I would say, is around legacy devices. Most of our customers, they have a mix of new devices, which are easier to connect. They already perhaps have built-in sensors and built-in connectivity capabilities. But if they look at their legacy devices, they need to do a lot of retrofit, and it's quite more difficult to connect those devices to actually, for example, prevent downtime, because that typically happens with your legacy devices, and that's also another challenge.
Totally, and if we take our own devices, looking back a couple of years in this industry and seeing how this capability evolved in terms of compute, in terms of networking, you have from small devices inside lamps to huge devices on the field and industry machines and things like this. So could you share some cases around this to make it concrete for people what do we mean and who is actually doing industrial IoT today?
Yeah, sure. So let me just share my screen here. So I would like to share 3 use cases today. The first one is around asset condition monitoring. The second one is predictive maintenance, and the last one is predictive quality. So these are the common use cases that we see our customers have already built, and they are actually using these type of capabilities for driving efficiencies across their operations. So starting from the first one, asset condition monitoring. So this is about connecting your industrial devices, such as PLCs, program logic controllers, or MES systems, to the cloud, getting the data out of those devices and use that to monitor the condition of the device and being able to detect any anomalies of those devices before that happens. So this will have huge benefits in terms of having that visibility across your operations and understanding what is happening, because a lot of our customers, they have got a mix of complex equipment and devices across, for example, in the manufacturing. And it's quite hard to understand what's the status of these devices and how they can correlate data from one function in one in one environment to the next one, and how these are all tied together. So having that overall, what we call OEE, or operational equipment efficiency, and monitoring that is the first use case I would like to talk about. And how this can be done, this is a sample architecture which can be done with, you see here AWS IoT Analytics, which is our new IoT Analytics capability. So you collect data from your devices. So this could be your SCADA devices, your factory machines, your vision systems that you use for quality control, for example. You process that data using Greengrass. Greengrass is our edge computing software. It allows you to do edge computing on site, to filter data, transform data, enrich data, maybe apply Lambda functions to process that data. And then you send that data to the cloud. And in the cloud, we have the IoT analytics capability, which allows you to analyze your data and prepare it for analytics. And then you can use anomaly detection models in the cloud, for example, using Amazon SageMaker. SageMaker, for those who are not familiar with, is our hosted machine learning service, which allows you to apply Jupyter notebooks, for example, to your data. And then based on that, you can raise notifications, email alarms that something is going to happen with your devices. So
I see. So the example case, for example, in this would be predictive maintenance, something like this, right?
Yeah, so this is for monitoring the condition of your assets. One example is this global mining company that we work with. So the challenge that they had was is that they across these huge mines, they use very large machines and trucks to carry all kinds of goods. And the maintenance costs of these machines are quite high. So they wanted to understand and to monitor the condition of the road, because the roughness of the road had huge impact on the on the condition of these equipments that they need to run on the roads. So what we did is that we installed a gateway on those trucks, and we collected data such as vibration from the tires of these trucks. And then based on that, we could calculate the roughness factor of the road, and we use that to provide visibility for them to understand, okay, where the road is rough, where is not rough, and then they can schedule their maintenance around that. So we could create a heat map like this.
Let me just highlight one point that I don't think may have been explicit enough. So we're talking about mixing the IoT device that is there on the field with the cloud data and everything we have there. So Greengrass is for those who don't know, Greengrass is the component that will bridge this gap, right? That will take care of the devices on the field and store data reliably and execute functions to compute, in this case, the state of the roads. But this lives on the trucks, right?
Exactly. That's a great point, Julio. So because these trucks actually are working in a very harsh and remote environment, so they don't have connectivity all the time. And that's exactly why we use Greengrass on the truck, on the gateway on the truck, to process that data and calculate this roughness factor that we wanted to calculate. And then we send the result back to the cloud for creating a heat map like what you see on the screen, that then the operators can use that and the drivers can use this to avoid those roads that are shown here in red, so they can schedule their maintenance around these conditions, and this visibility helps them a lot in terms of driving their costs down and having better efficiency across their operations.
Awesome. Do you have more examples of this kind of edge processing and edge services that could help similar users?
Yes. So the next use case I would like to share is predictive maintenance. So again, similar to what we have seen, you could also use the data that you collect to predict the failure of an equipment or an asset before it happens.
Yeah, and this is pretty important. As you said, it costs a lot to maintain those equipments. You can't send the technician either too early or too late, because too early is a waste of money, too late is a waste of lives, perhaps. So how do we get to that?
Exactly. So if you are able to predict the failure of those equipments, you can schedule your maintenance just before that happens. So, and as you mentioned, this will have a lot of benefit in terms of driving the cost of the maintenance down. But how can you do that? So here is an example of the architecture that you could use. So again, as you collect data from your machines, you can use now Greengrass to apply machine learning at the edge. And why do we have this capability is that for a lot of use cases, we see benefits around using machine learning at the edge. For example, some use cases you're limited because of the latency, so you really need to make quick and fast decisions at the edge. Or in some other examples that we've seen, there is issues with the bandwidth and with connectivity. So you don't want to risk that if your device is in an area that there is no connectivity, you can still want to, if you are going to predict a failure, you want to be able to do that. And so now we have the machine learning capability on Greengrass, and how it works is that you can collect data from your devices, and then you can train and build a machine learning model using the cloud. And why we want to do this in the cloud? Because for training and building a machine learning model, you need a lot of data, and also you need a lot of compute power. And obviously, cloud is the best place to do that, because in the cloud, you have a lot of compute power. So you can use that to build and train your model. For example, with Amazon SageMaker, which is, again, our hosted machine learning service. And then when you have that model, you can use Greengrass to deploy it back to your device. And then you can use Lambda functions to accelerate applications that you want to use for inference. And that can be done on the device. You don't need the cloud anymore, and it will work even if your device is disconnected from the network. And this is exactly the way that we work with a customer called Wärtsilä. So Wärtsilä is a manufacturer of engines for vessels and ships, and they had issues around the failure of these engines on their operations. So what they wanted to understand was to be able to predict the failure of these engines before it happens. So we deploy Greengrass on those ships. We collected data, and by deploying machine learning models on Greengrass, we were able to help them to predict the failure of these engines before that happens.
Awesome. And I see the scale of this 14,000 chips is like huge, right?
Exactly.
You can, and I guess this generates a huge load of data. Like, how do you make sense of all this data? Do I have to code it myself?
Yeah, so let me just share the last use case before we go to that part. So the last one is the predictive quality, and I will go through this very quickly. So in addition that you can predict the failure or condition of your assets, you could also do that to predict the quality of your output. So if you have a production line and you are producing something, in most cases the quality of the finished product is very important. So and then you can use the same setup that we talked about to also predict the quality of your output product. So let me just share with you one example. Walmart is a manufacturer of machinery for the paper industry. And if you look at the production line for a paper mill, what is really important is the quality of your finished papers in terms of the thickness. So you always want to keep that at a very optimal level. So what they did is they use AWS IoT Analytics to get the data out of their production line. They build a digital twin of that production line in the cloud, and by applying machine learning models, they were able to produce the output of the products. So now back to your question around how do you want to actually, when you collect all of this data, what do you want to do with it, and how can you analyze that data? So this is a great question. So what we see is that there are common challenges across the board with IoT data. So IoT data, they tend to be noisy. They tend to have gaps. Maybe your sensors are not calibrated. So usually you need to validate your data. You need to filter it. You need to pre-process it before even you can start doing analytics. And then you can have different type of analytics. If you want to do, for example, real-time analytics, if you have time series data, or if you have batch data, so these are different type of data that you need to manage. So we introduced the AWS IoT Analytics to actually make the analytics for IoT data simple and easy. AWS IoT Analytics is a managed service which is optimized for IoT data. It allows you to pre-process and transform your data, and also enrich it with external sources. For example, if you want to add GPS data or weather data, you can add that to your data, and then it has optimum storage for your data. It depends on what type of data you have, and if you want to do short-term storage or if you want to do long-term storage. And then when you have the data ready for analytics, you can do a simple query to your data, or it is integrated again with our Amazon SageMaker, which allows you to do more sophisticated analytics on that data. You can use, for example, Jupyter notebooks to do predictive analytics if you like. And this actually helps you to automate that process in a very easy way, instead of actually doing a lot of coding and manual work on your data.
Cool. So just to recap, we talked a lot about IoT in the industrial cases and the challenges that these companies and users face with these huge IoT deployments. We have IoT on the edge with Greengrass to run machine learning inside trucks, IoT analytics to understand telemetry data, and all you guys need to build this large-scale IoT apps. And we'll go deeper into the Greengrass part in the next segment, and I hope we'll see you next.
Okay, thank you.
Thank you, Amir.
Thank you, Julio.
Bye-bye.
Thank you. Bye-bye.